Here we go, exercise 5E. We're going on to pretty much the last part of chapter 5. We're putting it all together. Now you should know how to read set notations. You should be able to pick up on domain, know what a domain is. You should be able to sketch the graphs according to the domain, and we're putting all that together. Okay, we're putting all that together now. So exercise 5E, it's called hybrid functions. Alternatively, in your textbook, they also call it piecewise functions as well. I'll call it hybrid, just because that means there's a couple of different functions there. Hence hybrid. Okay? Let's start off. Before we get into sketching, because in part of the exercise, you need to know how to sketch a straight line. So I'm just going to revisit how to sketch a straight line again. So let's have a look at this function. I've got f of x, which is a replacement for your y variable. And you've got negative x plus 2. Now, what does it mean, boys? What does it mean when I say negative 1, and then you've got the symbol x, and then the symbol 3? What am I saying there? What am I trying to say about this equation? What's the negative 1 there? Tell me, Akita.
So x isn't equal to, but up to negative 1, and it is equal to 3, or up to 3, and it is equal to 3 as well.
Good. So what is the x representing? Not the x-intercept?
X value.
Yes, these are the x values. What's the proper name for the x values? 5b.
Domain.
Domain. Perfect. Exercise 5b. Okay, so in exercise 5b, we talked about domain. This just means in your graph, normally when you sketch your graph, you take all x values. In our case now, we're not saying we're going to take all x values. We're saying we only want to sketch between negative 1 to 3. So if you look at your x-axis, instead of going infinitely to the right, infinitely to the left, so for example, if you drew a quadratic graph, you would do something like this and go, it goes all the way out, right? But what if I don't want that? Yeah, in our case, I only want from negative 1 to 3. So, Ian, negative 1 to 3, what I'm really saying is part of the graph, I only want to sketch between there. I don't want anything more than that. Okay, but in our case, we don't have a quadratic equation. What do I have? What's negative x plus 2? What kind of graph do I have there? Finn, what kind of graph is negative x plus 2? What kind of graph do I have? It's linear, which means a straight line. So I got a straight line, and I just want to revisit again. This is the first chapter you learnt in methods, revisiting year 9, year 10, how to sketch straight lines again. Now, what does the plus 2 tell me? It is up, down, and it's not 2 to the right. It is up, down. So back to year 9 maths, besides knowing it's up and down, what's the plus 2 tell me again back in year 9? The straight line equation. That's the y-intercept. But why? How do you find the y-intercept? What's the only one technique that you want to know how to find the y-intercept? X equals 0. So if I were to let x equal to 0, you can see that it makes sense that if I put 0 in, that number is the y-intercept. But it only works for a straight line equation. Yeah, so a straight line, that does tell you the y-intercept. So I know the y-intercept is 2. So that's good. So 2, I'm going to label it. I'm going to say, all right, when x is 0, y is 2. It's a straight line equation, so I need to find now the x-intercept. How do you find the x-intercept, Sydney?
Y.
Good, let y equal to 0. So in the equation, I'm going to let y equal to 0. So this is my y value, let it equal to 0. Solve for x. How do I solve for x, Will? Good, move 2 to the other side, which I don't like the idea of moving. It's subtracting 2 on both sides, because that's plus 2. Subtract 2 on both sides, it cancels out the right-hand side. 0 minus 2 is negative 2. Now I've got negative x equals to negative 2. How do I get rid of a negative, Ryan? You can just cancel that, but I don't want to just, you can. How do you do it? Good. Both sides you can times by negative 1, or you can divide both sides by negative 1. Remember, balancing an equation, do whatever you want. Times or divide, add or subtract, it's up to you, but you got to do it to both sides. So here, times both sides by negative 1, and that tells me x equals 2. So now I know x equals 2, y equals 0. Those are my two x-intercepts, y-intercepts. And you told me it's a straight line. If I sketch a straight line, if I connect it, this is what a straight line equation will look like. So this is what you did in year 9. You would use your ruler, you would sketch the points, and you would have said, that's your y equals negative x plus 2. But In year 11, we're now going to try to integrate what we call the domain. See, the domain tells you only sketch the graph only from -1 to 3. So that means on your graph, I don't want any points less than this point. So that means it stops here, and it also stops at 3, which is only here. Closed circle. Fantastic. So if I were to sketch, I'm going to do it in blue so you can see. I only sketch this part. So from -1, it stops here, but this is an open circle. Whereas at 3, it stops here. So my line should only be, and I'll draw it in blue, right there. This is my straight line. Okay? I don't have anything that's red. All the red ones are gone. So when I sketch my graph, it should only look like that. Okay? So that's what the domain does. The domain tells you where, in terms of the x values, where I should sketch. In my case, it's only -1 to 3. That's what this domain tells you. Domain is only the x values. But if you restrict the x values, then you also restrict the y values as well. Yeah, because if you tell x to only -1. Exactly. Now, in order to finish off the graph, I still need the endpoints. See, I still need to know what these coordinates are. How do I find those coordinates? If I know this is x is -1, that's the endpoint. How do I find the y value? No?
What?
How do I find? Say it again. Yeah, listen to that. X equals -1. How do you find the y value? Sum. Not x equals 0. When you let x equals 0, what are you doing? You're finding the y-intercept. I'm not finding the y-intercept. I'm finding the endpoint. So logic, yeah? -1. I want to find the y value. Sub it into the equation. Now, if x is -1, I'm going to find the endpoints. So we go, good. Sub in x equals -1. -1 with the negative on the outside, 2 negatives make it positive. So you do get 3. So now I know this coordinate up here has to be -1, 3. So that's my y value there. That's 3.
But what does that mean?
Whereas at x equals 3, which is the endpoint, when x equals 3, I need to know the coordinates there too. So how do you find that out? Same thing. Sub 3 in. If you sub 3 in, what do you get? -1. So you sub 3 in. -3 plus 2, -1. So now you know that's at 3. When x is 3, y is -1. So what I'm trying to show you right now is you've just sketched a graph with the domain restriction. Now that's exercise 5B. So if this looks new to you or is confusing to you, that means you haven't done 5B. Yeah, and I said by Friday I'm expecting 5A, 5B, 5C. That's 5B. That's just talking about the domain. Okay, so domain. Now, that's why I'm saying if you haven't done your homework 5B, 5C, then doing today's work is going to be tricky because all you're doing today is you're doing 2 parts. It's the same thing. You're sketching 2 different equations with the domain given. Okay, so let's take a step back. Taking a step back, so this is your equation. The only thing you have to realize is the domain will tell you where to sketch and what to sketch. Okay, in this case, it's a straight line for -1 to 3. Okay? Now, today's lesson, 5E, I want you to copy this example down so that you understand what it means. 5E, copy this down. Ian. Thank you. Otherwise, you're going to ask me the same questions and say, what the hell again? Okay? Promise it's going to happen every session. Here we go. F of x. When you do these curly brackets, remember curly brackets only used for what? Listing items. So if you're listing items, in this case, I'm listing 2 equations. I've got an x squared and I've got an x. But the key thing, why do you say so? The key thing is the domain. So let's read the domain. When you say x is less than 0, that means for all x values that are smaller than 0, that's where I'm sketching. Okay, so let's have a look at the bigger graph. X less than 0, this is the x-axis where it's less than 0. Okay, so on that side, I will only sketch the quadratic graph. That's what it means. So it tells you, my function, I want you to sketch 2 parts. When x is less than 0, so when x is negative, I want you to sketch the quadratic equation. But when x is bigger than 0 or equal to 0, I want you to sketch a straight line equation, okay, which is y equals x.
It's gonna look like that.
So you get two parts, yeah, exactly. And that's why it's called a hybrid function, because you're just sketching two graphs into one, because you're splitting up the domain.
What is the x squared?
Yes, what's an x squared? It's quadratic. What does a quadratic graph look like again? What's an x squared graph look like again?
Oh, this is not negative.
Smiley face, good. In this case, if it's a positive x squared, is it a smiley face or a frown?
Smiley face.
Smiley. So this is what your graph normally looks like for an x squared, okay? What about an x? If I said y equals x,
0, 0, straight line.
0, 0 straight line, is it a positive straight line or a negative straight line? Positive, so it looks like this. This is a positive gradient, crosses through 0, 0.
Why isn't it a quadratic?
Because that's x there. So I'm just sketching y equals x. This is what linear line looks like. This is what y equals x squared looks like. Now, these are the two graphs. I want to only sketch the left-hand side left, which is x is less than 0. I only want to sketch this part. And anything that's bigger than 0, I want to sketch this part. So if you put them both together, yes, Felix? Why don't you end the brackets? You should. In your calculator, it would. But when we do it notation-wise, we don't do it. Don't know why. Just don't do it. You can, but don't do it. It's just how we do it in the exams. That's what you'll see. You won't see the end brackets for this one. It's just how we do it for hybrid functions. But when we're listing items, then we do need the end bracket for that. But when you're doing hybrid functions and you're labeling a function, we don't do it. It's just for hybrid only. You could. Yeah, and I'll show you in the third example. You'll see that you can have many graphs. It doesn't have to be 2, it could be 3, it could be 4, but it just means you have to change the domain into bits and pieces. Okay, so here we go. When we say x is less than 0, I've highlighted in yellow there. Yellow means less than 0, so here we go. On this graph, I want to sketch only the left-hand side, because that's when it's less than 0. So I'm only sketching that part there. I'm only sketching that part of the quadratic. So I'm going to do it in red over here so you can see.
Oh, wait. Oh.
I'm going to sketch, what the hell? Yeah.
Wait.
Here we go. This is when x is less than 0, I sketch x squared. See, this is my x squared graph. I'm going to sketch the left-hand side because it says x is less than 0. So when x is less than 0, which is this side here.
Be a straight line to the other one.
Yes. So exactly. So on the right-hand side, it says greater than 0. So it means I'm only going to sketch. I'm going to color in green here so you can see.
What the hell is this? It's going to be like a half.
In green, this is when x is bigger than 0.
Yeah, but what's the point there?
So this is the bigger than 0 part. I'm sketching that graph.
What's the point?
Don't ask the point. I want you to learn it.
I mean, like, what's the intercept? What's the intercept? The point.
You can work that out later. So, you want to work out which graph you're going to be sketching. In our case, it's greater than or equal to 0. So I'm only sketching this part.
So you know how it's two like double functions like x squared and an x.
Yep.
Okay, the big three.
Yeah, so
Wait, hold on a second. I'm listening to Ryan. So, you will have a straight line, and this is what it looks like. So you can see, this is your hybrid function. That's what they're asking you to sketch. You're sketching part of the quadratic, and then part of the straight line. That's why it's called a hybrid. Yeah. Now, Ryan, you asked the question.
Yeah, I did. You know how it's x squared and x?
Yep.
It would be like x cubed, x squared, x and stuff.
You can do that if you want.
So it'd be tons.
There can be many,
by the way,
because it depends on where you want to sketch it.
So by the way,
It's up to you how you want to sketch it.
Maybe.
Yeah, you can. And that's how, what you're asking right now is what they do. You see, like, you're learning all these functions, but in the real life, they will break it up so that, like, when you're making a, you know, like a sort of an architecture, and you draw sort of part of a cube like that, and it goes in a triangle, you see what you're actually doing, and like in an animation or whatnot, you can say, have a quadratic function here, but only between x equals, I don't know, 1 and -1. And then you'll say, sketch a straight line between -1 and 0, and then sketch another straight line between 0 and 1, and you can put up the shape. And that's what they do. But you don't do it by hand anymore, you do it on a software. You use the shapes, and you find the X-Intercept, but that's why you need to know the domain, because you only want parts of a graph. Sometimes if you want to draw, instead of a semicircle, you might want only half of it, or like a quarter of it. So then you got to restrict it from, let's say, -1 to 0, and you only get this part. You know, so it's all about learning to restrict the domain to get part of the graph that you want. Okay? All right. Wait. Does that make sense so far in terms of hybrid functions? You're just sketching two parts based on how many functions you get and how many domains you get. Okay, so if you get 3 different parts, then you'll have 3 different equations to sketch. Okay?
So,
Yes.
you know, like for the x, right? So, the x squared and 0 equals 0, so the point is 0.
Yes.
Yeah, but how about for the x squared? So, if less than 0, it should be negative point. Intercept.
But less than 0, you've already sketched the graph.
Yeah, okay. So, center is always 0, right? Center.
For this graph, yes. Because that's an x squared graph, which is sent to 0. But if I change that equation, then it wouldn't be at 0. Yeah? Alright, let's try another one. Let's try something a bit trickier. So this is the one that Sydney asked. Boys? Sydney asked, what if you had another equation to it? Now I made 3 parts to it now. I've got x squared, I've got x minus 1, and I've got a 3. And I've got 3 intervals. I've got when x is less than 0, when x is between 0 and 3, and if x is bigger than 3, and equal to 3, then this is the graph I have. So I've got 3 parts.
Wait, what if it's just 3? Does that mean it's just like a
Perfect. Yeah. Okay, well, in your textbook they won't do that. They'll have 3 different linear graphs. But here we go. This is your x-axis. Now I'm going to color code it on the x-axis. You said when it's less than 0. When it's less than 0.
It'll be quadratic, the same last one.
Good. So this is less than 0. You'll be sketching x squared. But if it's between 0 and 3, so I'm going to just label here, this is 0. Let's say 3 is here. Then from 0 to 3, I'll be sketching the x minus 1 graph. So in this case, I'm going to label in yellow. So 0 to 3, you only sketch x minus 1. But then after 3, I'll be sketching, I'll do purple. Purple onwards, I'll be sketching the graph for 3. It's pretty bad. I'm going to do that.
Empty spot at 0.
Yes. Very good. And you're going to have to use an open circle for that. So it's a very good point. So what you can see is I've color-coded the 3 parts. You've got yellow, green, and purple. And on my x-axis, I've broken it up. That means on the left-hand side, you're right. It's exactly like the last graph. It's quadratic.
Yeah.
And it's only up to 0.
And what's the graph for x? Y equals x minus 1. You have to work that out, do you?
Yes, you do.
For me, 1
Very good. So
equals negative.
let's work this out individually. Here we go. So we know the first one made sense. This is your quadratic. But remember, it says x doesn't equal 0. So at this point, I shouldn't have any points at this point. Yeah, at x equals 0, there is no x equals 0. This is x less than 0. This is x bigger than 0. None of it was ever equal to. So you should have an open circle at this point already. So this should be an open circle at 0. So this is my quadratic. There you go, open circle. I've done half my quadratic there. Now we're going to sketch our linear graph. X minus 1. So let's go back to our year 9 maths again. Y equals x minus 1. What does this graph look like? What's my y-intercept? Negative 1. So I got y-intercept is at negative 1. Okay, but that's when x equals to 0. You should have a y-intercept at negative 1. But I don't have it equals to 0. See, this is x is bigger than 0, or x is smaller than 3, but I don't have equal to 0. So at negative 1, you should have an open circle. Okay, because you don't have x equals 0. Does that make sense? Because in my domain, I never said x equals to 0 anywhere.
You mean not included?
Not included. So at this point, I don't have 0, but I do know it is, and negative 1 should be the y-intercept if x equals 0. But I now need to sketch the graph of x minus 1. Now what you need is an x-intercept. What's the x-intercept of this equation?
Y0, 1.
Good. Let y equal to 0. Solve for x. X equals 1. So that tells me this is what the graph should look like. But I'm only sketching from 0 to 3 of that graph. So 0 to 3 would only tell me this is 0, 3 is somewhere over here. Okay, so now you've got to figure out the endpoints, just like what I showed you before, which I'm going to show you over here. I'm going to highlight it in yellow. You only want from 0 to 3. So here we go, this is 3 here. I only want to sketch from 0 to 3. These are the only points I need. So on my graph, I should only sketch It looks like 0 to 3 over here. So 0 to 3. So here we go. I'm going to sketch 0 to 3. And it should not be including. Yep. They don't. No, they don't. Sometimes they will keep it connected, sometimes they don't. And in year 12, you'll get parts of the graph that connect, some parts of the graph that don't. Okay, now, let's work this one out. So, I got -1. I know that the X-Intercept was at 1 because I just figured it out. This is when it's 1, 0. How do I find this endpoint now? What's the coordinates of the endpoint, Lucy? Yeah, because you know x equals 3. When x is 3, this y value should have been x minus 1. Okay, so at x equals to 3, this should have been 3 minus 1. So you know this is now 3, 2. I'm just subbing 3 into this equation. When x equals 3, x minus 1 becomes 3 minus 1, which is 2. Okay? Write down. Seb. Thank you. Now this is where it doesn't have to connect. It will. It won't. Because that's a y equals 3. Now greater than or equal to 3, what's the line of y equals 3 look like? It's just straight, but it's a horizontal line, not a vertical line. When y equals 3, it's a horizontal line at 3. Well, it's just your normal 3-part question, so it's 2 to 3 marks. Right.
Not bad.
So, here we go, we've got 3, but because it says greater than or equal to 3, I should have a closed circle, and that's what it looks like. So you can see, this is my graph. See how I'm sketching all 3 parts? This is the purple section, y equals 3, but I only sketched this part from 3 onwards. Otherwise it would have gone infinitely that way too. For the yellow graph, I only sketched between 0 and 3, and I found out the endpoints. When x is 0, y is -1. When x is 3, y is 2. And then I sketch, when it's less than 0, I sketch the green part, which is the quadratic. This is called a hybrid function.
Interesting.
That was y equals 2. That means that it'd be control.
Perfect. It would then be filled in. If this was y equals 2, you would have a closed circle here, and then it goes infinitely. You're right. Okay, you're Felix. Yes, you should. Yes. So you do it like that. How's it feel? That's exercise 5E. Now, most of the exercises of 5E won't be this weird in terms of 3 different graphs. They'll have all straight lines. So that's why I try to revise how to sketch straight lines. But that's 5E. You're really just learning how to read the domain, how to sketch them individually. That's all you're doing. Okay? So it's reading notations 5B, and then sketching your graphs, what you've learnt in year 9, year 10. Okay? It is pretty cool. You can do that on your CAS too. Alright? Alright, here we go. That's exercise 5E. Let's practice 5E. I'm just going to pause the video.